And I'll tell you if that thing
So
ever
next year,
disappears.
guys, he's gonna only do that one part.
All right, so analyze each function for discontinuities, and then graph to determine the limits. So, do we have a discontinuity in the first one?
Yes.
X
one.
can equal 1.
So when x equals 1, we substitute in, we have 1 over
Zero.
0,
So that's
which
vertical
Infinite,
asymptote.
yeah.
makes this a non-removable
Yeah. C over 0.
discontinuity, which makes it a vertical asymptote.
At 1.
Yeah.
So now we got to figure out the limit as x approaches the discontinuity. So as x approaches 1, so limit as x approaches 1, and because it's a vertical asymptote, we want to see what it's doing as we approach from the negative side and from the positive side. So as x approaches 1 from the negative side of the function, and the limit as x approaches 1 from the positive side. So we're just figuring out what the graph is doing as we approach from one side and the other of the vertical asymptote. Right?
So 0.9.
Yes, 0.9 is good. Or 0.99 or 0.999, right?
I figured-
The closer and closer we get, the bigger and bigger the result is going to be.
Worse.
So, or smaller and smaller, okay? So, 0.9 would be on the negative side of 1.
Right.
So we have 1 over 0.9 minus 1 gives us what?
0.1.
Almost 0.1.
0.9 minus 1, so that'd be negative.
It would be negative 0.1.
Yeah.
And then 1 divided by negative something small is
something small.
negative something big.
Big. Oh my goodness.
Which means that the closer and closer we get, it's just going to be negative, but bigger and bigger and bigger.
It's 100.
So this is negative infinity.
Right. So that already means that it's the
So-
limit doesn't exist, right?
Well, we know the limit doesn't exist because we know it's going to be a vertical asymptote.
Right.
But now we're analyzing how the graph behaves as we approach.
Oh,
Okay.
okay. So like, because it could do this.
Right.
It could do
Yeah.
this.
Yeah, there's lots of different ways it could go.
It could.
So now let's do the limit as x approaches 1 from the positive side. So I pick a number that's very close to, but on the positive side of the vertical asymptote.
1.1.
1.01, let's say, right? So 1 over 1.01 minus 1 would be
0.01.
positive 0.01. 1 divided by something very small then,
There's some very big.
positive
So
big.
it's positive.
So this is positive infinity. So now it says graph. So we're going to just make a sketch. We have a vertical asymptote at x equals 1. So here's 1. So we draw that dotted vertical asymptote in there. And we know that as we approach 1 from the negative side, we're going to take off and go to negative infinity. So our graph does this. And as we approach from the positive side, we're going to take off and go to positive infinity. So our graph does this. And there's our sketch.
What do you call those functions again? Like the ones with the two, like 1 over x. What kind of function would that be?
Inverse.
Inverse function. Right. Okay.
Okay. So this guy, f of x equals 1 over x minus 1 squared.
So we have x minus 1 times x minus
Do we have a discontinuity here?
1. No.
Yes.
Yes.
And
When?
one.
1 again. So when x equals 1, what happens?
You can't.
1 over
Zero.
1 minus 1, which is 0. 0
Zero.
squared is
Zero
0.
squared is
So this tells us it's not a whole, which means it's non-removable. So that means it's a vertical asymptote. Okay, and then we want to figure out the limit.
As x approaches.
X approaches 1 from the negative side of the function. And the limit as x approaches 1 from the positive side of the function. So,
So when we pick point 9 again.
yep, 0.9, 0.99, something like that.
So
Plug it
1
in.
over-
Oh, it gets a positive number.
Yeah, so 0.99 minus 1 is 0.01, but it's negative.
But you're square.
But then we square it and we get an even smaller, but now
0.01,
positive
right?
result. So 1 divided by a positive small number,
Makes
Big
a
positive number.
big positive number, we get positive infinity.
And the same over there.
And then on the other one, it's going to be the same result. Because of the fact that we're squaring on the bottom, we're going to get a positive result every time. 1 divided by a positive small number is positive. Now when I make the sketch, my vertical asymptote
Is that one?
is at 1. So I put my dotted vertical asymptote in there. From the negative side, I'm going to positive infinity. And from the positive side, I'm going to positive infinity.
Do they still consider that an inverse function, or is that a different named?
Because it was being squared, something changed it, right? So, you know what, that's a good question. I'm not sure if it changes the name or not, but that's the graph anyway.
The parent function is still the inverse function, right? We're just
Yeah.
manipulating it.
We're just manipulating.
Yeah.
So this is a different parent function.
Yeah,
Oh, really?
it would be
Yeah.
1 over x squared would be the parent
Right, this is a
function.
new
Okay,
deal.
yeah.
Okay?
That's
maybe
why I
maybe we
asked.
just discovered something.
Maybe we did. Brand new.
Yeah,
Never seen before ever.
exactly.
Never forward.
I'd never taught this one before ever either.
Yeah.
Okay, this one, what's going on here?
We automatically have a negative. So the parent graph, you can assume, is going to be inversed. Well, not inversed.
We're going to assume things?
No, we're not going to assume things. You have negative. It can't equal 1.
It's,
X can't equal.
X can't equal 1 again, right? So what happens when x equals 1?
You get
It's-
1 over 0. Negative.
It's the
1 over
vertical
0,
asymptote.
We have negative 1 over 0.
which is non-removable.
Non-removable discontinuity.
Creates a VA.
What does that stand for?
Vertical asymptote.
No, no.
Association.
Yeah, the Veterans Association?
Okay.
As the limit approaches 1 negative or negative.
Limit
one,
as x approaches
Yes.
1 from the negative side of the function.
It's negative 0.1, which will be a big negative number, but then it's
But then it's negative, so
so it's positive.
actually positive infinity on this one. Limit, what am I writing?
X
As X
approaches
approaches
1 from the positive direction.
Good. Of the function. What are we going to get this time?
So 1.1 minus 1, that's 0.1, but it's going to be negative because there's a minus 1.
Right. Okay, so now we can make our sketch. Our vertical asymptote is at 1. Okay. As we approach from the negative side, what are we doing?
It goes.
It goes to
from
positive
here.
infinity.
Yep, like that.
Okay. And from the positive side?
It goes to negative infinity.
Yeah, so what happened to this graph compared to the one up here?
It like flipped, reflected across the asymptote.
Reflected across
The origin, right?
no and no,
The
X
x-axis.
axis.
the x-axis.
Right, yeah, it's the X
Oh, okay, yeah.
axis. I can see it now.
Okay, this one, slightly different than the other three. What do we do?
Well,
Negative
there's
2.
not a discontinuity in this.
Yeah, it is, negative 2.
Oh, I'm stupid.
I'm stupid, okay.
Okay, so
I get
if I
it.
have
Stupid.
negative 2 plus 2 is 0, 0
Yeah.
squared. Okay, so we do get 3 over 0 when we plug in negative 2, right? So when x
Yeah.
equals negative 2, what happens?
So let's do what, 1.9? Or negative
Vertical
1.9.
asymptote.
All right, what am I writing?
Limit
The limit
as
of x approaches negative 2 from the negative side.
Of the function.
Yes.
Okay, and what are we gonna get?
So negative 1.99 plus 2 gets you a positive number
Squared, positive,
but it's
a
negative.
negative.
So you're going to be approaching negative.
Okay. The 3 on top really doesn't make any difference.
Yeah, no.
It'll just change the shape of
Scalar.
the function.
It's a scalar, right?
But yeah, but it doesn't do anything as far as our negative infinity or positive
It's the
infinity.
A value?
Yeah, right. So it's like a stretch or compression.
Yeah.
Okay, what am I writing?
Limit
limit
as
as
x
x
approaches to
from the
negative
positive
2 from the positive direction of the function equals positive infinity, or negative infinity.
So what am I plugging in?
You're plugging in.
2, or negative 2 point,
Mm-mm.
no, negative 1.9.
Negative 1.99, something like that, because I'm on the positive side of negative 2.
Okay.
So that'll be to the right side of negative 2, so like negative 1.99.
It's a positive
It's still gonna
number.
do
That would give us 0.01
Yeah.
It's still going to be
positive,
negative
square it,
infinity.
even smaller. 3 divided by a small number, huge number, but it's negative.
Yeah.
Okay, so what does this graph look like then?
This graph looks like it reflects across the
No, it's
axis of the one above.
My
Well,
vertical asymptote is where?
negative 2.
Oh, it doesn't.
Okay, so I gotta go to -2. That's awesome. Okay, now what?
As it approaches.
It's
-2.
negative.
From which side?
Both
Neg-
of them.
Both sides.
Both sides. So this one's going like this,
It's a trick.
and this one's going like this.
See,
Try to trick you.
Okay?
your
Pretty
thing
good?
disappeared, by the way.
What?
Got you to look.
Well, you never know. Okay, so here we go. The first two that I just did, right?
Yeah.
Here's the graph officially. This is what it looks like. Our sketches were very close, but now this is actually what it looks like. Now notice the limit as x approaches -1. I'm looking at the graph from the negative side. We're taking off and going this way, so it's negative infinity. From the positive side, here we are from the positive side. We're taking off and going to positive infinity, so infinity. And that's what we wrote down, right? What?
Yeah.
Is there like a pattern? So when it was not squared on the bottom
Uh-huh.
and it had a positive, they went like that. But then when there was a negative in it, it flipped x-axis.
So what happened with the squared is it turned everything inside of that factor positive, no matter what we
because
plugged
then on the
in.
squared they both went up,
Mhm.
and when there was a negative, they both went down.
So a negative, remember, in any parent function, right, you have f of,
All right, so then as we approach 1 from the negative side, approaching 1 from the negative side,
Just positive infinity.
positive infinity, approaching 1 from the positive side,
Positive.
positive infinity. Okay? So all I'm doing here is I'm reinforcing what the graph is showing us because now we're looking at the graph and how to read the graph, right? So then the other two graphs are sitting here, the original function, the graph of the original function. And now as we approach 1 from the negative side, we are going positive infinity. From the positive side, we're going,
Negative infinity.
okay? And then this guy, as we approach from the negative side,
negative both ways.
negative infinity, and from the positive side, negative infinity. Okay?
Infinity.
We can read the graph?
Yeah.
Okay.
Yeah, there's irony in there.
So now finding vertical asymptotes. So remember the vertical asymptotes only occur
I just got
at non-removable discontinuities. Vertical asymptotes, non-removable discontinuities. The easiest way to determine the limits at an asymptote is to graph, and the limits at an asymptote do not exist, but we can describe the behavior by like pretending that they exist. Okay? And that's what we're just doing. So determine all vertical asymptotes of the function and describe the behavior. So if there's more than one vertical asymptote, you have to identify all of them and also describe the behavior at all of them. Okay? So on this first one, do I have any vertical asymptotes?
Yeah.
Where?
-1.
Okay.
Yeah.
How do you know it's a vertical asymptote?
Because 1 over 0 is a,
So if I plug -1 in, I get 1 over 0,
Yeah.
definitely non-removable.
non-removable.
Therefore, vertical asymptote. Okay, so I'm going to say x equals at x equals 1. -1. Then what?
Limit.
Wait.
X,
Non-removable.
Non-removable, yeah.
vertical asymptote.
I don't think there's any more, is there? Probably not.
No,
Vertical asymptote.
Now the limit, right?
So describe the behavior. So the limit as x approaches that, so -1, from the negative side, limit as x approaches -1, the positive side. So it's just like what we were just doing. You pick a number very close to the -1 on the negative side of -1 and on the positive side of -1. So what do we got?
-1.1.
Then you're gonna get a negative
Okay.
on the bottom, which makes the whole thing negative.
So we choose -1.1, plug it in. We got -0.1 or -0.01 or -0.001. The point is it's a small negative number. Times 2, still a small negative number. 1 divided by a small negative number is a big
Negative.
negative number. So our result is negative infinity. Smaller and smaller negative numbers plugged in give us bigger and bigger negative results. Okay, if I plug in a number on this side, so the positive side of negative 1.
Negative 0.9.
Negative 0.9, negative 0.99, negative
Positive.
0.999, doesn't matter.
Mhm.
Plug it in, what do I get?
You get
Positive.
Positive,
Keep
small
going, positive,
number,
positive.
smaller and smaller number.
Positive.
Times 2 doesn't matter. 1 divided by whatever that result is
Don't matter.
is a bigger and bigger result. So I'm going to get infinity. Okay? So that's how you do that. And so these guys right here are your answers. X equals negative 1 is the discontinuity, and then we have a vertical asymptote. So then the infinity and the negative infinity is what I'm looking for there.
It's
Okay?
probably the hardest section.
Yeah, it takes a little bit. The notation is the drag.
Yeah, because you have to write all.
Yep.
Is it like that the whole way?
Kind of.
The notation is just the drag?
Like as the year goes on?
Yeah.
No, not really.
Okay.
Intervals.
Okay, on this one, what do you see?
both
Squared.
They
So
can
I would,
get
I think you,
Did I just hear you guys say cancel out?
I said divide.
I did
I
not
didn't
say
made
that.
sure to
I
say
started,
divide.
I went cut, no. So I'm just gonna,
Uh-huh.
I did not
and
say
just
it.
out of curiosity, what would you decide to divide out if you were going to divide something?
Well, I
can't
was gonna
divide
try
anything
and,
You can,
well, you can factor the bottom, right?
Okay, the bottom does factor, yeah.
and you can
and-
factor the top, right?
Can I factor that top?
No. It's not a.
No.
freaking-
Oh,
Only
it's
the
not.
difference of squares factors.
If it-
The sum
if
of
it-
squares does not.
If there was another X on the top, like plus X, then you could.
Maybe. But the top does not factor. The bottom does.
But if we factor it, could we still divide something
If
out?
you factor,
Oh, no,
you're gonna
you
get
can't.
two vertical
No,
asymptotes,
okay, because
correct?
they have to be equal to each other, right?
So let's say we factor it. X squared plus 1 over x plus 1 times x minus 1.
So x can't equal -1 and x can't equal +1.
That's right.
Two vertical.
That's
what
right.
I'm saying.
So there's nothing to do here. There's no dividing out that can happen.
Okay,
Okay? Understand that. You can't do anything.
got it.
So we have x cannot equal, or x equals, at x equals,
-1.
Negative 1.
So could you put positive and negative there?
Oh, and
well,
then
you have to do these separately.
Oh, because you have limits set, yeah.
We have to do what we just did on the first problem for each of those vertical asymptotes, okay?
oh lord.
Because if I plug in -1, I get 2 on top and 0 on the bottom. If I plug in +1, I get 2 on top and 0 on the bottom. So both of these are vertical asymptotes. So we have to do this analysis for both, okay? So at x equals -1, it is non-removable.
Yeah, and at X equals 1, it's not removable.
Mm-hmm. Vertical asymptote. And same thing over here.
So the limit as x approaches -1 from the negative side of the function, you put what? -1.1, you get
A positive.
a positive.
And that makes the whole thing positive, big number, so positive infinity.
Yeah?
Yeah.
So -1.01 or something like that.
Yeah.
Square.
Turns positive slightly larger than 1.
Right.
Positive slightly larger than 1 here, -1 is still positive small,
Mhm.
right? On top, we get something bigger than 1,
Yeah.
right? Something bigger than 1 divided by something small, but positive, gives us
Creates a big-
positive infinity. Okay? Limit as x approaches -1 from the positive side of the function.
0.9, -0.9, you're gonna get squared is positive, -1 is a negative, and
So it's
you're
negative.
gonna still
So when I
have-
square something smaller than 1, like 0.9, or even -0.9, what is the result? Is it bigger than 1 or smaller than 1?
It's gonna be a,
Smaller.
It's slightly smaller than 1.
yeah.
Positive. Something slightly smaller than 1 minus 1 is
is a negative.
negative, big or small?
It's
Bigger than
gonna
1,
be
smaller
small.
than 1,
It's
a lot
small.
bigger, a lot smaller.
It's
small,
And
right?
then, but it
Positive or negative?
Negative.
negative.
Okay, so the bottom is small and negative.
And the
What about on
is
top?
The
big
top is
and positive.
Bigger than 1,
Yeah.
right? So we have a positive bigger than 1 number divided by a negative small number.
Gets you a negative big,
Gets larger, but negative. So what's my result here?
negative infinity.
Negative infinity. So I want to point out that at no point are we really actually calculating anything. We're just using logic to come up with what these numbers are revealing, right? And we do that a lot. Okay? All right. The x equals 1 now.
Oh, I forgot there's
Yeah,
the
there's two
limit
vertical
as
asymptotes
x
here.
approaches positive 1 from the negative side of the function. So
From,
you're gonna
you want to
have-
do the positive side first?
Yeah, well, let's switch it up.
Negative.
Oh boy.
Let's confuse ourselves.
Great job.
So what? 1.1 squared
Is bigger than
still
that, so
bigger
it's
and positive.
infinity.
Minus that, still positive, and it's positive small. And then 1.1 squared, that's just bigger than 1. So a big number divided by a super small number, it's positive, gets you to positive.
Like that.
So positive infinity?
Yes,
Positive.
You are correct.
that's the conclusion I came to.
Yep,
using
that's
multiple
right.
Words that
And now with the 1 from the negative side, so this time we're choosing what number?
0.9.
Like 0.9, 0.99, something like that.
0.9 squared is going to give you still a number smaller than 1 that's positive,
That's
minus
why
a
this
number
is
bigger than
like
1
this.
gets you a negative.
So the denominator here is negative.
Negative,
The numerator is
positive,
positive bigger than 1 divided by a small negative number.
negative big number.
Negative big number. Negative
I
infinity
like
is
how
the
we're talking
result.
in like not English.
Yeah.
Calculus.
An Algebra 1 or 2 student in here would be like, what is going on, right?
I remember, do you remember when Mr. Jordan?
Big number produces small.
All the way back in Algebra 1, he just did one of these calculus problems, like just one of the days. I think you probably were asking some stupid question, and then he just did like a huge math problem. It's like, does that solve your answer for you? And you're like, no. And then you touched his beard and he bit your finger or something like that.
Yeah.
Direction copy.
All right, how do we do something
Keep
like
that in the
this?
recording.
F of
So-
x equals...
We need to figure out where
Cotangent.
cotangent equals 0.
No, before we do that, what should we do, maybe?
We should look at where it would be undefined.
There's going to be a smarter way to do this.
Well, it's
Cos-
just
oh, 1 over
Sine.
tangent.
Or
Right?
cotangent is
No, cosine over sine.
Okay,
Cosine.
cotangent is 1 over tangent, but tangent is...
Oh, so we just need sine to be
Sine or
So
cosine.
it'd be
sine is
cosine over
0.
sine.
So it's cosine x over sine x.
So we just need to figure out where sine is equal to 0.
And that's why we switched it.
Ah,
Now we know
we're
that
good.
where is sine 0, that's where we're going to have a problem, right?
Yeah.
Okay, so when is sine x 0?
Pi over 2 and 3 pi over 2.
Yeah.
No.
No, it's
Sine is
pi.
0 is pi.
It's 0 and 2 pi. And pi.
So all of the integer pi's.
0,
pi-
pi,
0
Pi
pi, 2
Pi
pi,
k.
3 pi, 4 pi, 5 pi.
pi plus
k.
pi k.
Pi times
Yeah.
an integer, right?
That, whatever that
Pi
is.
k.
We usually call it, so it's 0 pi, 1 pi, 2 pi, 3
4
pi,
pi.
and so on, right?
Yeah. All the
We would
pi.
call that n pi.
Oh, n pi?
How come we used k back in pre-calc?
I don't know, that was dumb. You use n for integers.
Okay.
Okay, so it's n pi. Now the question is, as we approach that integer value of pi from the positive side or the negative side, what is the asymptote doing, right?
Oh, I can see it on my side. It goes like this.
Now we can use the unit circle, okay? So on the unit circle, we have the integer values of pi here and here, right?
Yes.
We can use the unit circle and choose one of those. Which one do you, which
Let's
one's gonna be
go
easier
pi
to
over
work?
6.
Okay, so you're saying let's use this,
Yeah.
okay. So pi over 6 would be here,
And pi over 3.
and then
No, wait,
over
and-
here would be the other side of
Yeah,
that
so that'd be
asymptote.
11 pi over 6.
Okay, we can say 11 pi over 6, or we can say negative pi over 6.
Okay, yeah,
Either
let's
way.
do that.
Okay, both of those work.
How's that your asymptote?
Because the asymptotes occur at
Oh,
these
it's in
integer
that-
values.
okay.
And this is 0 pi right here, right?
So it just makes it a line at the x-axis.
Okay. So now we're going to say the limit as x approaches
Pi over 6,
0
0 pi.
from the negative side of the function, and the limit as x approaches 0 from the positive side.
Don't know their calc.
Because of the periodic nature, because of the periodic nature of the trig functions, we know that it's going to be the same. The repetitive feature is it's going to be the same at every single one of these integer pi values.
Yeah.
Okay, so we just need to figure out one of them. So, from the, coming in from the negative side, if I'm looking at a number line, zero's right here. If I'm coming in from the negative side, which value do I need to pick? We said this guy or this guy. So which one do I need?
Negative pi over 6.
Negative pi over 6 or 11 pi over 6,
Yeah.
right? Either one. So now we
Which
need
is-
cosine divided by sine at that location. So what's cosine going to be?
It's going to be 3 pi over 2.
No,
No.
we're at 11 pi over 6.
The
It would
value
be
of cosine.
negative a half.
The value
Negative
of cosine at that
Negative
location
square
Negative
root of
3
2.
pi over 2. Or 3, negative root 3 over 2.
is
Ah!
root 3 over
Yeah.
2.
Because all students take calculus.
Yeah.
Oh, it's still
Cosine is positive.
The location here of the x coordinate,
It's
that's your x coordinate, that's positive.
Yeah.
And what's the y coordinate?
The y coordinate is going to be negative 1.
The y coordinate's negative 1/2. So we gotta divide by the y coordinate, which is negative 1/2.
So we
And
just
the
Leave
top
it,
is
change it,
bigger.
flip it, what do we get?
root 3. Negative.
Negative root 3.
So it's,
Okay.
yeah, it's getting
Flip
bigger
over
from the
twos.
negative
So
side.
see.
we got
So
a
it's-
negative result. This, as we get closer and closer to 0, is just gonna keep getting bigger and bigger and bigger. We got a negative result here, so what does that tell
It
us?
approaches negative infinity.
This one approaches negative infinity.
Poof. My brain's starting to.
Okay? Now, on this one,
So
as
it's
we approach from the
this-
positive side, we're coming in this way. So which value do we want?
Pi over 6.
Pi over 6. We're up here.
So that's
No.
going to be root 3 over 2
Root
over
3
a
2
half,
divided by a half.
which is going to be
It's going to be
Over
positive
root
3. 3.
root 3.
Positive, we don't really even care about the number. We just care about the sign, right?
And
We
it's
know it's
positive.
approaching a vertical asymptote. We're already positive. What are we gonna
I
be?
saw a sign.
Positive.
Positive infinity.
Thumbs up meant positive. And so tangent would be kind of like the reverse,
Tangent would
right?
be, yeah.
So where you go like
I
the,
don't know.
okay,
We're probably going to find out in the next page in all sincerity.
Okay?
sincerity.
So that's how you figure that out. Now, the reason that we got like root 3 and not something huge is because we were actually pretty far away from 0.
Yeah.
You know, we were way down here. But we used the unit circle to help us come up with those answers rather
Right.
than sitting there trying to figure it out on a calculator, which is not
Indeed.
as powerful. Okay, determine all the discontinuities of the function and describe the behavior.
Well,
You can factor, that's gonna be, so,
X
let's see
minus
here.
4
We
and
have
X
one
plus
hole,
2.
I see one hole.
Okay, so you said factor the top. What was it?
X minus 4 and X plus 2.
You can factor
Or no, X plus 4 and X minus 2, my bad.
Okay, and the bottom?
x plus 2, x minus 2.
Yeah.
Okay, so what happens here?
Ooh, they divide out the X minus 2.
The x minus 2's are gone. Now,
So that's a
that,
hole though.
that's a hole. That is a discontinuity, and the directions were determine all discontinuities.
So your discontinuity is.
So we have x,
At X
We have
equals
remove.
2.
X equals 2, yeah.
x equals 2 is a
Hole.
Hole.
removable
Removable. Yeah. And you were right,
And it's
hole.
not
Hole.
the-
Yeah.
Okay, describe the behavior at that removable hole.
So that would mean you take what's the rest of it, right?
You say the limit as x approaches
Is
2 of the function
and
is,
So you go
It's
2,
positive.
so you got 4 over 6, which is 3.
It's positive.
6
now we can direct substitute into what's left over here. We have 2 plus 4 over 2 plus 2,
Which is
6
one-third.
over 4, 3
Oh
halves.
my goodness, oh my goodness.
Ah.
Okay?
Okay.
All right, so that took care of the removable one. What about the non-removable? Because we do have this x plus 2 on the bottom that we couldn't take care of.
Well, at -2.
So
X
when
equals
x equals -2, what is it?
A non-removable vertical asymptote.
An NRVA.
NRV.
No. All right, so then we got to do the limit as x approaches -2 from the negative side of the function, and the limit as x approaches 2 from the positive side of the function.
So we're going to have 1.99. 1.9 plus 2, that gives you.
We're gonna have.
Oh, we're at negative 2.
Negative, this is a -2 right here.
Negative 1.9.
We're gonna have -2.01.
Yes, that's what I meant to say.
Okay,
You're gonna have a negative.
So yeah, negative plus a positive. So a negative number that's bigger than 2 plus 2 is going to still be a negative number over a negative plus. So it's going to be a big positive over a small negative. which
So
gets
this
you to
is-
negative infinity.
negative infinity.
Guys, I figured out how to solve infinity.
Now, interesting point. We divided out right here, so we can use the reduced, after we did this right here, we can use this one to figure this out,
Multiplying 0 by 0. correct?
okay? How about from the positive side? What number are we using?
1.9.
-1.9, -1.99, something like
Yeah.
that? Okay,
So a number less than 2 that's negative plus 2 gets you a positive small
positive
number
small,
over a positive big number.
Okay.
So you get positive infinity.
positive infinity is the result. Okay, so that is what would be expected on a problem like that. You found a hole, you evaluated it, and then you found a vertical asymptote, so you evaluated it. Okay?
Okay.
How about the second one?
Can't break that down.
The top one?
Break it down.
Two
It'd be
numbers there.
x times x minus 3, and that doesn't do any good for us. So there's
Oh, you're trying to factor that?
yeah.
What if we use the
I factored-
factor
yeah.
meter?
There's nothing there.
Okay, yeah, there's nothing to divide out there, unfortunately.
So there's 1 at x equals 1.
Okay, x equals 1. What do we have?
A
Non-removable discontinuity. Which makes it a,
Vertical
VA.
asymptote.
okay, and so now we evaluate it.
Limit as x approaches 1 from the positive side of the graph, and limit as x approaches 1 from the negative side of the graph. So 0.9 minus 1 gets you to a negative small number over 0.9 times. That just gives you.
So just use logic. This factored form here is actually easier to work with. So 0.9 on the outside is positive. 0.9 minus 3 on the inside is negative.
Negative.
Positive times negative on top is negative. On the bottom, what do we have?
Negative.
Negative small. We have a negative on top divided by a negative small on the
Which
bottom,
is a positive.
which is a positive result, so we are going to
Positive.
positive infinity, okay? The factored form is easiest to work with, and that's why a lot of times we don't multiply anything out in this class, okay? We like factored form. How about this one? Coming in from the negative side.
So we
Didn't we-
have a small,
Actually,
We
that
flipped it.
was the,
That was the negative side.
you reversed it on me. This was the, we're just gonna do this. Negative, positive. Okay, that's better.
now from 1.1, we have a positive.
What-
It's,
what number
Positive
did
times
we
a
pick?
negative on top.
1.1.
1.1?
So a
So we're
positive
gonna
times a
have-
negative, which is negative on top, over a
Positive.
positive, so negative.
So
Negative on top, positive on the bottom?
Yeah,
So the result is
Negative.
negative. So we're going off to
Yeah.
negative infinity on this one now. Okay,
Oh, Lord.
we good?
yes.
That mistake will forever hold on your conscience
I know.
because it'll be on the internet forever and ever and ever.
That looks,
Okay, so now we're gonna talk about infinite limits.
Infinite.
C and L are real numbers, F and G are functions, and here are the rules of this page. The limit as x approaches C of f of x is infinity. The limit as x approaches C of g of x is capital L. So what does x approaches C of f of x equals infinity mean? What are we dealing with in that case?
You're dealing with vertical asymptote.
Vertical asymptote, yep. The function's going off to infinity on that vertical asymptote. X approaches C of g of x equals L.
You're dealing
That
with
means
whole
the
numbers.
limit actually exists there. Okay, so the sum or difference, the limit as x approaches C of f of x plus or minus g of x. So f of x is going off to infinity on the limit. G of x actually exists there. Doesn't matter. When we add those two things together, we're going to wind up with an infinite limit.
Because you have infinity plus
One took off to
3.
infinity. Yeah. It just doesn't work. Product.
That's so bad.
Limit as x approaches C.
Infinities.
I have one function that took off to infinity, one function that was something. we're gonna be an infinite limit there. As long as the limit that I knew was greater than 0. But it will be negative infinity if the limit that I knew was less than 0. So if this guy here is positive, then I'll wind up at positive infinity. If it's negative, I'll wind up at negative infinity.
This is that fancy notation.
I only have 2 real words on this entire page.
That makes sense. And then the third one there, if I divide those two, so if I know this limit here, and it's just a number, an infinitely huge number on the bottom with some number on the top, a bigger and bigger number on the bottom with some number on the top is just going to give me a smaller and smaller result. And the bigger this number on the bottom gets, with this number staying the same, is just going to give me smaller and smaller and smaller until eventually I'm 0. So that one hopefully makes sense. This is an infinitely huge limit on the bottom. This is staying steady at whatever number it is. So that's going to
I
result
guess
in
it
0.
kind of makes intuitive sense
Yeah.
because
Yeah, it does.
0 is just
I thought.
anything over an infinite number. I guess.
If I have anything divided by an infinitely huge thing, it's going to wind up 0.
Yeah. Because you can't have. Yeah.
0 is just the
But infinity
absence of
over
numbers.
infinity is still infinity.
It's an indeterminate form.
Yeah.
You can't
What if
come
what
up
if
with
you
an answer.
what is what
It's
if
just like,
what if
wait.
what if f of x is over g of x?
So then you'd have an infinitely huge thing divided by a number.
Yeah.
That's still just an infinitely huge thing.
Okay. So
All
it's
right.
just still infinity.
Are we good?
Yeah.
Okay. So we just practiced a little bit. We have the limit as x approaches 0 of 1 plus 1 over x squared. If you direct substitute that 0 in, you have 1 over 0, which is an infinite situation. So this would be 1 plus infinity. What's the result?
Positive.
Yeah.
Yep. The next one, we have the limit as x approaches 1 from the negative side of x squared plus 1 over cotangent pi x. What do you think?
So 0.9, which is still positive.
First of all, what's cotangent?
Cosine over sine.
Cosine over sine.
Cosine
So you
over
put
sine.
Sine times x squared plus 1, right? To make it easier.
Yeah, we could switch that. Are you saying break it apart?
Yeah.
We
break
can
it
switch
apart
that.
in thing.
So x squared over cotangent x pi x plus 1 over cotangent pi x. We could do that if you wanted.
No, I was talking about like
But what is 1 over cotangent then?
that's tangent.
That would be tangent. So we switch that into tangent pi x.
And could we break the second one apart further, or would that be too
So you're
much?
gonna have
No, we would leave that alone.
Okay. that would
But
be too
what is x squared? Can I direct substitute there?
It's just x times x.
much. 1.
Well,
That would just be 1 on top, right?
Mhm.
Okay, so what's cotangent pi
cotangent at pi. which
as we
is-
come in from the negative side? We just talked about it.
So it's negative, it's undefined, right? Cosine over sine?
But as we come in from the negative side, we just talked about what it is. It's like you
Right,
probably
right,
wrote it
right.
down.
It's negative pi. No, it's pi. No, it's
So this is 1.
it's pi.
Zero.
It's infinity. It's positive.
It's either infinity or it's negative infinity.
It's positive infinity.
You sure?
Yeah. Yes. If it's 1 on the top, yeah, it's positive infinity.
I better go back. Let's see. Where was it? Here it is right here. As we come in from the negative side, it's actually right here, negative infinity. Okay,
I
so
mixed it up.
we go here, and actually we don't need to split it up. This is just 1 right here. 1 plus 1 on top is 2 over cotangent pi x. For coming in from the negative side, we just said is negative infinity. So what's our result?
0.
It's actually just 0.
Huh.
Or
Wait a second. Can I plug that into a calculator to see what it looks like?
You can. What's your question?
well, because when you have 2 on the top and then cotangent, like cosine over sine,
Mm-hmm.
cosine at pi, is 0 over 1, which is 0, right?
But we're coming in from the negative side. So the division by 0 here stops us,
Okay.
right? So we have the limit as x approaches 0 from the positive side of 3 cotangent x.
Whoa.
Okay, so anything bigger than,
So coming in from the positive side of cotangent. We just looked at it again.
Yeah.
What is it?
It was positive infinity.
Positive infinity. So we have 3 times positive infinity. What do we got?
positive infinity.
Yep. Okay, and the last one, coming in from the negative side of 0, x squared plus 1 over x.
Okay, well, you're gonna have 1
Zero.
over 0.
I can direct substitute on this guy, that's 0, plus
1 over 0.
1 over 0.
That's,
That or a negative number.
But it's a negative
Zero.
number, so it's got to be
Coming in from the
Positive.
negative side, which would
positive
be,
infinity.
so negative infinity. And so we get
Negative.
negative infinity. Okay, and that's how you handle problems like that, all right? It's really just logic.
Okay.
Make sense?
Yeah.
Kind of?
Yeah.
Okay, that's it for the
makes
section.
sense.